Good evening and welcome to another episode of the first and only call-in show dedicated to the simulation hypothesis. This is home of the Neon Alliance. I am the one and only RAO. And today we're going to be diving way the hell out of my league. I called into this show, Talk Heathen, to discuss the simulation hypothesis and explain it, help get a better understanding of it, because I feel like I had the evidence. And I didn't want to go with speculations on the double slit experiment. What I was doing was going with the information from Dr. Sylvester James Gates, University of Maryland, I believe. Physicist, tenured, retired tenured physicist there and all that. Come to find out, all I was doing was saying, smart guy says math. And I didn't understand the math. I feel like I failed you. Honestly, I feel like offering that as evidence and not being able to explain it properly was a failure on my part. So today we are going to dive headfirst into this math, and we're going to see if we can get some kind of grasp for it. Now, this came from Freck, another content creator who was taking snippets from the Isaac Asimov debate, I believe, and from different things that Dr. Gates has said. So I'd like to watch that first with you so we can kind of get an understanding of what we're dealing with without diving headlong into the math first. But before I do that, I had heard that my Patreon is having some issues with people getting onto it. I do myself promotions later, but I'm going to drop you the link for the Patreon right now. That way you can get to it if you want. But now that we got that stuff taken care of, let's dive into this and see if we can learn something.
Partly it's taken to these very strange images that are behind your head right now. These are pictures of equations. I've been, for the last 15 years, trying to answer the kinds of questions that my colleagues here have been raising.
And I'm showing it you with the pictures because it's going to be damn near impossible to understand with the pictures and with the video. I wouldn't expect you to even try to understand it without it.
And what I've come to understand is that there are these incredible pictures that contain all the information of a set of equations that are related to string theory. And it's even more bizarre than that, because when you then try to understand these pictures, you find out that buried in them are computer codes, just like the type that you find in a browser when you go surf the web.
You're saying your attempt to understand the fundamental operations of nature leads you to a set of equations that are indistinguishable from the equations that drive search engines and browsers on our computers.
That is correct. So,
Wait. I have to just be silent for a minute here. So you're saying as you dig deeper, you find computer code writ in the fabric of the cosmos.
into the equations that we want to use to describe the cosmos, yes.
Computer code.
Computer code, strings of bits and ones and zeros.
It's not just sort of resembles computer code,
okay, there has to be something wrong. Like flat out there. Give me just a second. Let me get back over here. Um, this video was published May 31st, 2012. The debate that they got the footage from was in 2016. I don't know, maybe it got republished or some, I don't know right now, but I think that it's possible that I accidentally found evidence for time travel. While looking for this, because like I said, the video that we're watching was published 4 years before the debate that the footage was pulled from. Things just got a lot deeper.
You're saying it is computer code.
It's not even just is computer code. It's a special kind of computer code that was invented by a scientist named Claude Shannon in the 1940s. That's what we find buried very deeply inside the equations that occur in string theory and in general in systems that say are supersymmetric. Some of those codes are showing on the screens behind you right now. They don't look like codes, but these pictures, which we call adinkras, are graphical representations
Right there.
of sets of equations that are based
Published
on
May 31st, 2012.
of our universe. That is a supersymmetrical universe, which we're going to test in the LHC. If you believe that description, I can show you the presence of those codes. That's my statement.
Do you have any predictions in your ideas, or any ways to test any of your ideas any more than saying the guy on the screen?
The work that I'm doing is in fact so theoretical that we don't understand yet whether it is even possible to complete the program. We have found these strange graphs. We know that they are equivalent to equations, and we have found in these equations computer codes. And so that's where we are right now. So I cannot give you a prediction. This work is less than 2 years old.
But it's not that you.
And that's a problem that we're facing, and a problem that I've discussed with Tommy Wood, is that these ideas are so new that we don't even know what predictions we would be looking for yet. We don't know enough to say we don't know enough. We don't even know what questions to ask yet.
You recognize that you will need a prediction in order to.
Someone recently asked me, said, well, you don't care about experiments, do you? And I said, no, that's exactly wrong, because you see, I have spent my career as a researcher worrying about supersymmetry. I would want to see an experiment before I shuffle off this mortal coil, so I know that I did not waste my entire professional life.
And that's where I'm at, is I want an experiment.
Curious about your theory. You say there's computer code in these equations. Now, computer code is generally just instructions for a processor. I'm curious as to what the instructions you're finding are, and if you're not sure what's to say that it's actually computer code. I mean, theoretically, the number for pi has all the data that's ever existed.
Well, we say that they're computer codes.
I mean the digits in pi.
Yes.
Yes. Good.
We say they're computer codes, first of all, because of the structure.
And that's not entirely accurate either. Because pi is never going to give you strings of ones and zeros. That's just, it's not how pi can work. If it starts getting you strings of ones and zeros, then it becomes more of a repeating decimal. And it's not going to have, like, you're not going to find computer code in the digits of pi. It's just not going to work.
Of the equations, but they dictate there are certain things that are actually strings of ones and zeros. That's just digital data, but it's not just random 1, talk about something that you probably do every day, but I don't know if you're a computer scientist or not. Most of us sit at our
Sounds that kind of fluency.
okay, well, most of us sit at our computer screens and we type on the keyboards, and we then send these. If we're using a browser, we're sending strings of ones and zeros elsewhere. But on the other hand, in the transmission process, there's always some fluctuation. So zero that you type here because it's static in line might be read as a one at the other end, and vice versa. So in fact, when you sit and type on the keyboard, your computer's doing something behind your back. Namely, it throws in a bunch of extra ones and zeros, and these things are called error correcting codes. So that the computer at the other end can look at the whole collection of what you typed plus what was sent and figure out if there were bits that were being flipped back and forth. And that's how you get accurate transmission of digital data. Among the codes that are used for this purpose are a special class of codes that are called block linear self-dual error correcting codes. They were first, in fact, the Shannon extended checksum code is an example of one of these things. These are the codes that we find buried in the equations. Not just any code, but these self-dual error correcting block codes is quite remarkable for a computer because I've talked. We have no idea what these things are doing.
Literature out?
I'm sorry?
Do you have any literature out that
I can give you technical references that almost nobody in the world can understand.
And that's another problem that we're facing now. I can give you technical references, technical manuals that almost nobody on earth can understand. That is a problem for the skeptical, like in regards to communicating with the skeptical community, because there are so few people that understand it that it's not like you can just peer review it the same way you would with a lot of other things. Like in World War II, we had a whole lot of different countries working on the same things at the same time. We can't have that here because it's not rocket scientist. It looks like it makes rocket science look like eating a jar of paste. And so that is a problem when you're trying to prove something, is there aren't enough people that understand it to prove it.
But Jim, I thought you had a popular level article on this?
Thank you. Yes, actually, so this past June, the British journal Physics World asked me to write a popular level description of what we have found. So in the June edition of Physics World, and this is published in London, the cover story is called Symbols of Power. It's about these weird symbols that have been showing behind them. We call these things enigmas. So for a popular level description, yes, we've written that. But other than this one popular level description, it's all technical gobbledygook. And that's a technical term.
So we've got technical gobbledygook at this point, and one popular reference. That's the level that we're dealing with right now. Is we have one thing written that people can understand. So, what do? We're going to go to the one thing that people understand, that everybody can understand. And this is Symbols of Power, Adinkras and the Nature of Reality. It was published by James Gates. Okay, so let's cut out the time travel shit, because I don't think that's happened, because this was published April 8th. So he might have been... This might have been a script that he and Tyson have been doing for a while, and that takes way less assumptions that, like, you know, two physicists have a script. That takes way less assumptions, so, like, we didn't discover time travel. Damn it. Maybe next week. But in case you're on your phone, and I'm going to have to read through this with you because I haven't read through it yet because I want to learn it with you. Let's see how long it is. See how far we can get into it. Physicists have long sought to describe the universe in terms of equations. Now James Gates explains how research on a class of geometric symbols known as adinkras could lead to fresh insights into the theory of supersymmetry, and perhaps even the very nature of reality. Complex ideas, complex shapes, adinkras, geometric objects that encode mathematical relationships between supersymmetric particles, are named after symbols that represent wise sayings in West African culture. This adinkra is called this adinkra is called, I'm going to do my best to pronounce this thing, Ni Anum Nosua Uhu, which translates to he who does not know can become knowledgeable through learning. I actually find some, I think about that at kind of a different level, because if you don't have knowledge and you know you don't have knowledge, then you can learn, you can understand. But if you already think you got knowledge, not to hash back on, I'm not going to bash him too much, but someone claiming to have eternal wisdom isn't going to be capable of learning anything else because they already have eternal wisdom, so they don't need to learn. And I prefer to stay ignorant. I prefer to always know that I can know more. And it keeps me learning, it keeps my mind fresh, and I like that. In the land of theoretical physics, equations have always been king. Indeed, it would probably be fair to caricature theoretical physicists as members of a company called Equations R Us, since we tend to view new equations as markers of progress. The modern era of equation prediction began with Maxwell in 1861, continued through the development of Einstein's equations of general relativity in 1916, and reached its first peak in the 1920s with the Schrödinger and Dirac equations. Then a second post-war surge saw the development of equations describing the strong force and the electroweak force, culminating the creation of the standard model of particle physics in about 1973. The equations trend continues today with the ongoing struggle to create comprehensive equation insert word here, to describe superstring theory. This effort, which aims to incorporate the force of gravity into physical models in a way that the standard model does not, marks the extant bounty of a long tradition. Alright, so that's interesting. A less well-known but much more successful example of geometry applied to physics is Murray Gell-Mann's eightfold way, which is a means of organizing subatomic particles. This organization has the underlying explanation using triangles with quarks located at the vertices. I'm so sorry about that. Now, the reason I find that so interesting is because of things similar to Bat Chin Dao, the Buddhist Eightfold Path. And it's probably a post hoc rationalization that somebody heard it and they used what they heard and related it to the superstring geometry. It it could have been called something else, but the dude was probably interested in Buddhism. I'm just trying to find something in here that actually like talks about the math, because I'm like, this is a whole lot of explaining the explanation. So, ooh, we got something here. The weight space diagram shows the baryon octet, a group of particles including the proton, the neutron, and 6 more exotic species known as herperons. Particles are arranged according to the isopin, how they interact with the strong nuclear force, and the number of strange quarks that they contain, their strangeness. And that just kind of shows that's a demonstration of what these particles look like. And then they formed the adinkras, oh wow, and then it gets into these multidimensional adinkras. And these are 3-dimensional shapes, 4-dimensional shapes, I think. I don't know. I'm going to have to read through all of this again. Well, I'm going to have to read through all of this. But then this is what they were talking about here. With the computer, with the 1s and 0s being here and the error correcting code. Well, the 1s and 0s being here on the top and bottom of this one. And from there, it goes into what the computer is transmitting. And what the computer is transmitting is a whole bunch of things, so that it's basically sending the same message as many times as possible, so that the receiving end is getting the best information possible. And that's the error correcting code, is sending out more 1s and 0s so that the computer knows if it missed something. And then this is more specific to what I was talking about, and associated to computer words. And the adinkra is shown with dashed right lines, life in the matrix. Alright. So, if you're not a theoretical physicist, and you want to have a better understanding of this, I'll get you the link right now. I should have put this link in the description. I'm going to go ahead and drop it into chat so that you can get it in the live replay whenever it's at your convenience. And I'm going to be looking more into it as well. Like, seriously, I have to, now that I've found the paperwork and discovered that this is not going to be understanding the math as much as I wanted it to be. What it is going to be is more of a lesson about dogma and understanding evidence. Because we can't just say this person has evidence. We can't just say that somebody said something. If you want to use something as evidence, it is best to make sure that you actually have some idea of what you're talking about before you just go spouting off smart dude said math. Because, I mean, those are the kind of problems that got us into religiosity. Is somebody smarter than somebody else said something. And that's actually, I think that's how con artists were made too. I think that was like the foundation of con artists, is somebody smarter said something to somebody who wasn't as smart, and they were just like, oh, okay. So yeah, if you don't want to get conned, if you don't want to get taken advantage of, dig into the evidence. Do your best to understand it for yourself. I'm not saying that you're always going to be able to understand it. But I am saying you're never going to understand it if you don't try. Alright, so I'm going to go ahead and drop that Discord into the chat. And do the shameless self-promotions right quick. Because it's that time. I mean, it's a shorter episode than we're usually used to. I'm not debating Tommy. I don't have co-host this time. The episode, I don't feel like this one was I don't think I failed you at this one. I think that I'm going to have to dive deep into this situation, into this paperwork, and get a better understanding of it. But if you want to support me, like I said, I've got that Patreon in the links on the chat. It's the one and only RAO. You can also find me on the on Twitch, the one and only RAO. And you can check out the gaming site. But with that said, we actually have a caller and a welcome guest. We have got Disco Tom on
Twitch, the one and only RAO.
And I'm gonna need you to shut me the hell up.
I did.
Alright. So, yeah, I looked into it and I Dunning-Krugered myself, dude. I thought it was gonna be easy, and then I looked into it and found out how freaking hard it was. It's like, oh, I'm not gonna be able to handle this live in one episode.
You're still there, or did I let you?
No, I'm still here.
Okay. Yeah, no, I think that was some awful self-deprecation at the end of your.
Some what?
segment there because I found it very interesting and very intriguing. And I thought it was very thought provoking. And I was gonna, you know, I was gonna start. I wasn't sure quite where you were going with this episode. I know you had spoken about the Dinkers before, but I think one of the nuggets that I got out of it was why in the hell are these uh, pictures they're coming up with in lab exist already in West African culture? That's what I want to know.
Well, no, it was it's basically the West Africans had a name for these words of wisdom that they were writing. It's like the you miss 100% of the shots you don't take. And somebody wrote that in an artistic style, and that's called that was the origin of Onychris. Now,
So, is there any correlation between the Adinkras in West African culture and the Dinkers they came from? It's not just bears.
uh, it feels more like it was a comparison, and it was just something they named him after. It didn't look like the strings of mathematical code were in the West African pictures. So that, yeah, it just looked like something they said, oh, this kind of looks like this, so we're just going to call it this for the sake of, like, being more familiar. Because,
Right, yeah. That's common term. I got you.
yeah, because we are in complete unfamiliar territory at this point, so if we can have a little bit of familiarity, that's a good thing.
That's true. Yeah. I actually have three books I picked out from my shelf that I wanted to share. Because when I was first beginning my journey into reading, I wanted to uh, the there's a group of people that are for the protection of or the AI alignment. So we've got there was a list of books that I was supposed to read, and I read some of them, not all of them. I kind of went off on my adventure.
Wait, are you talking about, like, human rights for AI?
No, 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 no. Alignment, which is making their goals aligned with ours in the beginning, at least. I mean, we can't control that. That's pointless. But I was just going to say that my point was the universe is mathematical, so it's not surprising that we find mathematics or even patterns within the equations of the universe, because even though there's sets of numbers that cannot ever be calculated because they're infinite, that doesn't mean that the universe is mathematical. You know, doesn't mean the universe is limited or not limited in any way just because sets can be infinite. I don't even know what I'm saying right now.
Well, yeah, that's what... Technical gobbledygook.
Yeah, exactly.
And that's the technical term. We heard it from James Gates. But no,
That's
like...
so confusing.
Right, and when I first started looking into these, I was finding symbols that I've never seen in math, and, like, I dipped into calculus, but I didn't, like, go into the whole class, and there were more Greek letters in these equations than there were numbers. And that's another thing I think is funny. People are like, oh, mathematics, it's all Greek to me. Oh, yeah? Get into real mathematics and it actually becomes Greek.
Yeah, exactly.
And that's more or less what I'm doing here is more than trying to push somebody to understand the evidence. Like, I also wanted to inform people of how difficult the evidence is to understand.
Uh,
And it's going to be a journey for us to get to that level of understanding.
I feel the same way because the way the world is, people are getting lazier and lazier. They want technology and services done for them, and they don't, you know, they want to learn their trade and make their money and retire, and they're not thinking about the future as far as where we are specifically right now in the realm of possibilities of AGI and maybe something out very shortly.
Wow. This is going to be a change for you because I'm actually going to go the Dalai Lama route on this one and tell you that people aren't thinking about the present for that exact same reason. Nobody's living in the moment and trying to explore between instant gratification, between worrying about your health in the future, anxiety from the past, like the sorrow from the past. You're working for your health, and then your health goes and you have to work, and it's an endless cycle, and it doesn't let anybody sit back and think anymore. And without the ability to sit back and think, with being just overworked, overrushed, all that kind of stuff, it's a really good way to create drones.
It is.
And we're getting way off of the subject because we are getting into different and other types of philosophy. I mean, we tend to do that. We tried to have a debate last week, and what it turned into was a conversation about consciousness. And I don't mind that at all. I love it. It was a Sunday on Tommy Wood's channel.
We did get a comment on there that I gave a like back to. It was very, check it out if you can find it. I don't have the name in front of me, but they made a very astute comment on there about potentiality for the future of AI and consciousness. I thought it was very interesting.
But yeah, I think that we're going to call this one an early day. Next week we are going to have Ed Penny on to talk about his book.
Nice.
You remember the Maladalas of Madness or something like that? Now I can look it up. I've got him on Facebook.
I'm not familiar.
Hold on. Give me just a bit. Ed Penny. And it's called oh, dang it. Oh, and he likes Facebook God. Not yours, the real one. But I'm looking for that right now because he did publish something on the simulation hypothesis, and I'd like to talk to him about it next week.
Nice, that's gonna be interesting.
So, and I can't find. Oh, I know, it's in my email. I know where to find it. Don't worry. We got this. We got this.
Cool.
All right. Madaba Madness. So I wasn't that far off. Madaba Madness. So yeah, that's what we're going to be doing next week. Is Ed Penny's going to be on here to talk about his book, and I'm going to be discussing it a little bit with him.
Awesome. So he's a simulationist.
He's what?
He's what?
One more again, please.
So he's a semi with us, right?
Yeah. I actually met him in the simulation theory group.
Oh, cool. That's gonna be awesome. I'd love to join the chat with you next week if I'm able to.
And it is kind of funny because we have such a small community that
Uh,
like the people who actually like look into it and study it, there's only a few thousand of us.
wow.
Like there's people who do we live in a simulation, do we not, like, but the people who are convinced that we do live in a simulation are so few and far between. I'm probably one of maybe 5 or 10 in this state.
Dang.
Well, I live in this. I live in the least populated state. So,
uh,
I
oh,
think
that's
I think we're actually gonna call this one a show, though. Tom, it's always amazing to have you on.
yeah, man.
I don't see
Thanks for
any.
having me.
I don't see anybody else waiting in queue. So, until next time, keep it real.
All right. Thank you.